show you a couple of things real quick. This is the original lead bell that they made. I don't know where the new one is. They had made a new one. This is broken a little bit, but how good a bell is it?
Not so good.
That's very good.
Minus 200 degrees. What's that going to do to the atoms in this lead?
It's closer together.
They're
Slow
going to get
down.
closer together.
Yeah.
Okay. So when you see me put this in, what temperature is this?
70.
70 degrees. Okay. It's going to go into minus 200. This is extremely hot compared to this. So it's going to make this boil. Just watch everybody's got closed-toed shoes on, right? Okay. Watch what it does on the tabletop. Watch it bounce across the tabletop and vaporize. Well, it's boiling inside. Let's do this. That has to be in there for a little bit. A little bit more.
You want me to take pictures?
That would be awesome.
Oh, I love my
You get at least a couple.
I heard you say.
Okay, watch it behave on the surface of the table here.
Whoa.
Can you see the little beads?
Oh, yeah.
I'm not going to dump a lot.
It's like our cloud chamber over again.
Only a much better version.
The little beads.
All right.
They're not touching the table.
They're gliding.
They're just gliding across the vapor.
Now, why aren't you worried? I mean, why do you have us standing this far back?
Well, because I'm used to handling it.
Yeah, he's aiming them all at us.
If I burn myself, I got nobody to blame but myself because I'm not being careful enough. If I burn you, we got a real issue.
Okay,
I'ma call you
especially
everyday
when the fire
crime.
department's standing.
Guys,
And you're sort of pouring it our way too. I mean, things are rolling.
Yeah.
The liquidy part's rolling towards us.
when I pull it out, I'm going to let it drain a little bit
Don't
before I touch
splatter.
it.
Yeah, just like that.
Now, is it any better bell now?
Better.
It would be even better if it wasn't broken off at the. But you can hear a change in the sound, an increase in the pitch. Okay. If I were to drop this now,
It would shatter.
okay, it would literally shatter like glass. So I want to set it down very carefully and let it warm back up. All right, we'll come back to that in a minute. One of the cool things about liquid nitrogen is how it changes volume. You see a lot of the gas expanding across the tabletop here as it warms up, and before it hardly, by the time it hits the floor, it's gone. It's evaporated. It's boiled away. I told you there's liquid nitrogen in here. I asked the kids, how many balloons can I fit? Now they don't, when I do this, they don't know there's liquid nitrogen in the container. I just take the top off. So we're going to put balloons in this cooler today. How many can I get in?
10.
What are they going to say?
One or two.
One or two?
Yeah, one or two.
Okay.
It's like the Mary Poppins first.
Yeah.
You know, they're looking under the table.
They're not hearing any pop, so
Oh, now that one's cool. I like that one.
Okay.
It looks like you're dissolving them.
As many this year.
There's one on the floor.
Oh, why do I have the gloves on?
Protect your hands.
These are cryo gloves. Several $100s a pair. So you're not going to just have these sitting around your lab, I know.
Don't use UV gloves.
But again, you could rent them from the company that rents you the.
And they protect you from the cold, but not from the wet.
Correct.
So get them soaked.
Now,
They're gonna be cold.
I do this for a couple of reasons. One, to show the change in volume. Because kids will say 3 or 4 maybe. You can get hundreds of balloons, obviously, in here. I actually did one year, got 110 in, there was still tons of room. So it just goes on and on. But what I want you to see now is liquid air. We blew these up this morning, just with air from our lungs. So there's CO2, oxygen, a little bit of water vapor, who knows what else.
Coffee vapor.
Okay. But a lot of teachers have never seen liquid air before. Now I'm gonna bring this up and I'm gonna walk in front of you over here. Look at the very bottom. The moment I bring this out, the balloon is gonna start to expand again. Why?
It's warming up.
Okay, gas is gonna warm up from the temperature, the heat in the room. The molecules will gain energy.
They're dancing around.
I relate all this back to our kinetic theory unit. This is one of the climax activities of our kinetic theory unit. And the balloon is going to expand fairly rapidly. But in the bottom, you're going to see kind of a whitish liquid. About a tablespoon, or half a tablespoonful of liquid air. You see it? You see the shadow? You see the shadow?
Oh, why don't I have my camera?
Now,
Oops.
that's why you don't carry it over the kids' heads. Okay? In front of them, they can see the shadow, just like you did. They normally don't pop. And just when I say that, it did. I usually get helium quality balloons. These are just dime store birthday balloons, so they're not quite as strong as the helium balloons. Okay.
He's gonna mop that
Jim,
up.
I have a question.
Liquid, yeah.
About how deep was the liquid nitrogen in the
I've got a couple inches in
in
here.
the styrofoam? Pardon me?
I have a couple inches.
Couple inches? Okay.
Yeah.
I want you to get this glass.
Just because I need to get rid of them, I'm going to put these out, but don't come.
That's the
back
fun
over
part,
yet.
to watch them blow up on the table. And there's still little beads of liquid nitrogen tumbling over the surface of the table.
Automatic reinflating balloons.
here, let me serve you la balloon.
A regular banana.
Deep fried. Deep frozen.
Isn't that what you can do with it?
Yeah, you can see the blue one's indenting,
Yeah. Yeah, it's got holes in it.
probably from your tongue.
Probably.
Yeah.
The last figure we got was, you get 2 liters for 32 cents. That's maybe
Here?
what FermiLab gets it for.
That's what FermiLab gets it
You're not
for.
gonna do that
Yeah,
one.
right.
Welder for that.
Yeah. It's a moneymaker for everybody else who's selling it.
Yeah.
You just buy large quantities, so they.
Why? Because he picked it up and water will shift as you will sloshing.
Yeah, the liquid.
Sloshing.
Yeah.
Oh, okay.
Okay, let's,
Doing the weight.
Yeah.
which exact experiments they will do for you just depends on the physicist and their own particular choice. Fresh daisies.
Freeze-dried, chamomile. Poppy.
I like how it's flowing out of the cooler.
It's actually the water in the
Yeah.
flowers that's freezing.
Oh,
Just like fine glass. I didn't have any roses this morning. I had to buy a rose because the roses, for perfume, they freeze dry the roses and use the scent then from the pieces to make perfume. And it concentrates the smell
So much.
tremendously when they do this. I'll clean your table in a little bit.
Oh, okay.
I don't know if I can get this one to do it or not. Hydrangea sometimes will. Sometimes it's so cold the pieces break right off.
Yeah, right? That looks like
See what we get
Like
here.
when you fry something, what is popping is the water that's
Yeah.
rapidly expanding. It's going from above, it's going to flash into a gas.
I almost threw a little plink there.
Ouchie.
One more, quick. Oh, the banana. Let me get the banana out of there.
Somebody's lunch.
Well, doesn't the banana turn into like a hammer?
This, you have to be aware if you do this in your classroom. Oh, I want to do that.
Golf ball? I mean,
Keeping track of your stuff. The kids will want to pick up the banana pieces and put them in their mouth.
Yeah, no, that is
Okay? So, and when I do this one, they're going to want to touch the pieces of the racquetball, and they can't do that either. Just a normal racquetball,
okay.
very elastic.
What's your hand?
Is it not as dangerous right now for you, is that why they leave the fire department a lot?
Oh, no.
No, they were here to-
No.
Yeah.
They were just here to watch.
Are
they doing something on it? They were
They heard the motion in here, and just got sucked into the cork system here. If I hadn't seen them out there, I would have known that, I would have thought that they were from Jim.
The gloves are too thick for me to hold on to the nail. I should have brought a longer one.
Is the nail gonna fall out?
Banana ready?
No, you can hammer the nail down. It's banana.
And the tailpipe.
Oh.
Because it's so hard.
Oh my god.
You can actually pound a nail. Balsa wood works better. You don't want to be sure it's going to work.
Wow, that
Should we
banana.
pound a nail and go more with
Banana
banana?
split in half.
Yeah.
That's cool.
Now this is really dangerous right now.
Because it's sharp.
extremely cold. It's still minus 200. Anywhere near your skin, it's going to burn you. So you need to be, again, be very conscious of where your stuff is on the table. Keep your kids away from it. The racquetball, which had extremely good elasticity.
Now, it
Probably
says
the size
minus
of a
200,
walnut.
that's Celsius, it's minus 320
And there's
Fahrenheit.
gonna be frozen air inside the racquetball, correct?
Yeah.
Pocket?
I'm going to do this over here because I want to be sure that the pieces
The shards.
aren't near you. Listen to this. You heard the racquetball hit the floor before. Listen to this
You
now.
gotta get this video.
Wait a sec. Let's probably get it.
Wow.
Now don't touch the pieces. They will become pliable actually very quickly again. Really quickly again. But I don't think they do that when they do a tennis ball here sometimes.
We just thump it on the table. We don't do a whole lot of breaking because it's.
Yeah, liability with kids, sure. So you'll see something like that, but it's a great way to bring in the kinetic theory to all of this, molecular motion, the relative terms of hot and cold. I always start this by asking kids, what do you think cold is? 30 degrees, 20 degrees. Would you go out in your swimsuit to that? No. Well, how much colder is dry ice then than zero? And we talk about getting to absolute zero where all motion stops.